All right, this is lecture 8.2, and this is a calculator heavy lecture. So if you don't have your TI-84 next to you as you watch this, please get it because you will need it. Okay, so this is section 8.2. As I said, the essential standard, I understand how to seed and obtain random numbers from my graphing calculator. I understand how to design, conduct, analyze, and report the results of a simulation. All right, your graphing calculators can generate a pseudo-random numbers, okay? This capability can be found by pressing the math key and looking under the PRB menu. So let's go and take a look. That would be, let's see, where's my math key? Here's my math key. And once I have hit the math key, I'm going to see this window right here. And it's the, you would cursor over to this PRB. On my calculator, it is PROB for probability. And you will go over there and then you can see that I have this option RAND. This function RAND generates random numbers between the interval of 0 and 1. Okay, so if you don't do anything except just hit RAND and hit enter, you'll get a number between 0 and 1 random numbers. Okay, just one number. It is also used to seed the pseudo random number generator. Okay, even though this is called a random generator, number generator, it's not a true random number generator. The calculator actually has to start. It has an algorithm that it's used to calculate those random numbers, and the seed value is where it starts. So let me give you an example. Maybe it starts and adds 900, then subtracts a number, and then adds and subtracts to generate that. The seed number just tells it where to start. Okay, so the ability to seed allows a user like yourself or other students to repeat a simulation with the same set of random numbers again if needed. So if you use the same seed, you set a number, up the calculator to spit out a list of random numbers, you'll get the same exact random numbers. So they're random, but they're not truly random. It also allows students to get the same random numbers on different calculators. So if we seed the calculators the same, set the same commands, then we should get the same random numbers. So the teachers can verify that students use their calculator appropriately on a test. So let's go ahead and do that. So what do? We will hit, we will plug in, we're going to seed our calculator with 10. So we're going to type in 10, okay? And then we are going to hit this arrow key right here, which is located to the left of 1. So it's right there. And then we will go to our math, go to probability, and go to RAND. So you'll go to math, cursor over to probability, make sure you hit 1. You should see something like this and hit enter. And you will see that 10 was entered. We have just seeded our calculator or told it to start at 10 if we were to generate a list of random numbers, and we told it to seed at 10. And we would do the same thing for 33. Okay, so there will be instructions, I'm sure, on a question where you are told to seed your calculator, and you need to know how to do that. All right. There are additional random functions in your calculator. We have a random int cap function in that menu, same exact menu where we have gone to math. Under probability, you'll see that I have a few different options. Rand int, which is 1, which we can enter in the lower, upper, and number. It returns the specific number of random integers constrained by a lower and upper limit. So instead of maybe 0 to 1, maybe you want to go from 1 to 10. And how many numbers do you want it to generate? You could tell it, give me 3 numbers between 1 and 10 that are randomly selected, and so forth. Then we have random int no repeat. So we could actually use number 8 where we will not allow it to repeat. And again, I can tell it a lower and upper. Some calculators only have this, where I have a TI-84 CE calculator, and I can give it a lower and upper and tell them how many numbers I want. Okay, so let's do some examples and use these functions, seed our calculator, and use these random integer functions to generate some random numbers. And you should get the exact same number that I get. Okay, so the first thing we want to do is seed our calculator with the integer 45. So we will plug in 45. We will use my arrow key, which is to the left of 1. We will then go to math and scroll over to probability, select rand, and hit enter. Now we have seeded our calculator at 45. We've told it we want to start at 45. Now we're going to generate 5 random integers between 2 and 8. So we are going to generate random integers between 2 and 8. So we will go to math. We will scroll over to PRB, or mine says PROB. We will scroll down to, mine is option 5, and it asks me for lower upper, and I'm going to give it a lower number of 2. That's what I've asked for. The upper is 8, and then in mine it asks for n. So how many numbers do I want? I want 5 integers, and I will hit enter, and my numbers come out to exactly these right here, which is 55228. And notice I have some repeating. Okay, so we didn't ask for a no repeat, so we have 2 5s and 2 2s. Okay, now we're going to reseed our calculator. So we're going to hit 45, arrow, math, go over to probability, hit ran. I've reseeded it, and we are going to generate 3 random numbers between 2 and 8 without repeats. So we will hit math. We will go over to PRB, or probability, and then go down to rand, integer, no repeat. Our lower is 2, our upper is 8. I have asked for 3 random, or I could leave it blank and not tell it how many I want, and it would just give me this list if you don't have a CE calculator. And if I want 3, I'm going to take the first 3 numbers. Okay, and those would be 2, 8, and 5. Okay, all right, hope that makes sense. Make sure you know how to do that. All right, when studying or analyzing events that contain randomness, it is sometimes difficult or impractical to conduct an actual experiment or find the theoretical answer. In cases like these, a simulation can be conducted. We will simulate that, okay? We'll use our calculator to do that. So when performing a simulation, you must fully explain your procedure so that it can be replicated and verified by another individual. Here is the steps for performing this procedure. You must specify the possible outcomes. Okay, so we're going to tell what kind of outcomes there are. Okay, flipping the quarter, there's only 2 outcomes, a head or tails. You must state the theoretical probability associated with each of the possible outcomes. Okay, if I have a quarter and I'm saying heads or tails, the probability of its heads is 50% and the probability its tails is 50%. You must describe an appropriate probability model for your simulation. How are random numbers mapped to the possible outcomes? Maybe you'll assign 1 for head, 2 for tails, and you will use your random calculator to generate a list of numbers between 1 and 2 randomly. So you have to give it's a legend, so to speak. You must clearly specify what constitutes one trial, as well as the number of trials that will be performed. So that depends on the experiment and what they're asking for. How many trials must you do? And you must conduct your simulation and record your results. So now we're going to actually run it. And then you combine all the information for your trials and report the results of your simulation. If for some reason you know the theoretical answer, your results could be compared to that. All right, so let's go ahead and do one of these. We have a fair coin. It's tossed 5 times. What is the probability of obtaining 3 or more heads in a row, okay? Use 22 as the seed for your calculator for this simulation and report your results after trials. Okay. First thing, you must specify the possible outcomes. So what are my possible outcomes? Well, I have heads is one possible outcome. The other possible outcome is I will obtain a tails. What is my theoretical probability? It's 50% for heads. It's 50% for tails. We're going to use a number that on my calculator, I'm going to generate a random number and I'm going to assign 0 for heads. So if I have a 0, it's a heads, and I'm going to assign a 1 to tail. So now we have, let's see, this is step 3. You must describe an appropriate probability. We are mapping the outcomes to, so mapping the outcomes of my random calculator, random number generator to what they mean, okay? What constitutes one trial and number of trials? So we have to determine. So we are going to toss this 5 times. So I'm going to have this random number generator generate 5 numbers and look for, do I have numbers that are worth 3 heads in a row? If it is, it passes. If not, it fails. So what will we do? We will use a calculator to randomly generate um, 5, not numbers, but integers from 0 to 1, because those are the only 2 that have meaning. 0 will represent a head, and 1 will represent getting a tail. Okay, we will look through the numbers. Let's see, and see if 3 or more zeros are present in a row, actually. If so, we have success. If not, we have failure. We will repeat 10 times because they said this, 10 trials. Oops, I'll stick with black. Repeat 10 times and calculate the number of trials. Let's see, hold on. We will repeat 10 times. What do they ask for? Report your results. We repeat 10 times. We will determine probability of getting 3 in a row by dividing number of success by 10. So let's run it. So let's see. Okay, use 22 as your in your calculator. So we're going to seed our calculator. So what do? We go and hit 22 arrow rand. So we're going to hit 22. We're going to hit the store button, which has a little arrow over it. We're going to go to math. We're going to scroll over to probability. We are going to hit rand and hit enter, and you will see something that looks like this. We're going to generate random numbers between 0 and 5. So we're going to hit math. We're going to scroll over to probability. We are going to math, scroll over to probability. Then I would select random integers, which is option 5. I'm going to hit my lower as 0 and my upper as 1. And I want a total number of 5 integers, and I will hit enter. And I did something wrong, so we got to start over. So I'm going to seed my calculator. I am going to hit, I want to generate random numbers. So option 5 between 0 and 1. There, perfect. Okay, and now I have this as my first option, and I can just hit enter again, and then I get this option. And if I hit enter again, I can just continue hitting that. And so I'm now going to go look at the data and determine which ones were true. Now remember, the ones that had zeros were heads. And what we wanted to know is what is the probability of obtaining 3 or more heads in a row? So we are going to go see if we had success or if we failed. In the first set of random numbers, you should get the same list too, by the way, if you seeded your calculator properly. I do not have 3 zeros in a row. I failed. The second one, I have no 3 zeros in a row. I failed. The third one, I failed. The fourth one, I failed. The fifth one, I failed. The sixth one, I failed. The seventh one, I failed. The eighth one, I had success. I have one that has 3 zeros in a row, and I failed the ninth and I failed the 10th. And so there is my data. And then the results of the simulation are that we estimate the probability of getting 3 or more heads in a row and 5 coin flips to be, how many do we get? 1 out of 10. Okay, that is a probability, which is also equal to 0.1 either way. All right, let's do another one. See if it's starting to make sense. George makes 70% of his free throws, so he makes 7 out of 10. What is the probability that he misses at least 2 of his next free throws? Okay, seed your calculator with the integer 61 when conducting the simulation. All right, possible outcomes for his shot. Well, what is his outcomes? He could make it, or he could miss it. Okay, what's the theoretical probability of making it? Well, they said that he has a 70% chance of making it. Therefore, he has a 30% chance of missing it. Well, let's represent making it by numbers 1 through 7 and missing it for numbers 8 through 10. So I have 1 through 7 is going to be my number that says, yep, he made it. 8 through 10 is my numbers that said he missed it. All right, what constitutes one trial and the number of trials? So what did they ask us for? What is the probability that he misses 2 of his next three throws? So we're going to have 3 total numbers, and we want to report a total of 10 trials. So we will use calculator to randomly generate 3 random integers between 1 and 10. The numbers 1 through 7 represent a basket. The numbers 8 through 10 represent a miss. Okay. We will look at 3 numbers. And see if 8 to 10 appears 2 or more times. Because that's what they're asking for. At least missing 2 of his next free throws. If so, it will be I'll call it a success, even though it's a miss. If not, it fails the test. Okay. All right, then what we do? We will repeat this 10 times. And determine the probability of George missing the next 2 out of 3 shots. All right, so we have, let's go do this. So we're going to seed our calculator. They told us with 61. So we will hit 61, we will hit our arrow, we'll go to math, PRB, and hit rand, and we should see something that looks like this on our screen. And now we have given the calculator a starting point. We have chosen the numbers 1 through 7 and 8 through 10. So we need to generate random numbers between the number of 1 through 10. We need 3 random numbers because we are looking at 2 of his next 3 free throws. And so we will hit math. We will go to probability. We will scroll down to option 5, which is random integers. I'm going to start at 1, so that's my lower. My upper is 10. I only really need 3. So n is 3, so there's 3 numbers, and then I will hit enter, and my first results show 5, 3, 8. If I hit enter again, I get the number 7, 9, 2. If I hit enter again, I get 9, 10, 8, and so forth and so forth. And now we will go and look and see with these 10 runs if I have a success or if I fail. Okay, so what are we looking for? We are looking to see that he misses at least 2 of his next free throws. Okay, so I need to miss at least 2 of his next 3. So I need 2 numbers between 8 and 10. So the first one fails, I only have 1 8. The second one fails, I only have 1 9. The second one passes, so this is a yes or a success if you'd like. The next one is a fail. This is a fail. This is a fail. This is a fail. This is a yes. I have 2. I have a 9 and a 10. I have all 3. So that one works. And this one I have no, okay, or fail. So I have 3 that were successful. And so we can now report our results. We estimate the probability that George missing the next 2 out of 3 shots to be 3 out of 10 or 0.3, either one. Okay. All right, that's the end of our lesson. I hope your lesson makes sense. I'll see you in our next video.